All right, so last time we learned the fundamental counting principle, which was about making choices and filling in slots. And we were able to count like the number of passwords, the number of different like sandwich configurations. And now we're going to look at a different counting method, which covers problems when you're making a small group from a big group. So when you're making groups, the fundamental counting principle it doesn't always work. So whenever we're making a small group from a big group, we are going to use the methods we talk about today. So making a small group from a big group. Oh, this is what happens when I try and talk and write at the same time. Let me small group from a big group. All right, so I'm going to write a question down, and we're going to take a look at it. So let's say that, so here's going to be our example, and I am going to pick, so I will pick 3 students from class, from this class. Let's say there's 28 people, so there's 28 students in the class, right? I'm going to pick these 3 people from this class and give them extra credit. All right, everybody loves extra credit. All right, and so the question is, how many different ways can I pick the 3 students? How many different ways can I pick 3 students? Okay, so the answer is, well, it depends. It depends on how I'm going to pick them, what is actually happening. Okay, so for example, let's say that I want to pick it so that the first student gets 100 points extra credit. Woohoo! 100 points. 100 points extra credit. All right, and the second student gets 50 points extra credit. All right, and the third student gets 10 points. Okay, so in this method, like if I'm picking people and they're getting different things, right? So if Savannah got picked first for the 100 points and Miguel got picked second for the 50 points, right? Savannah's going to be happier than Miguel, right? Because Savannah got 100 points. So Savannah getting picked first and Miguel getting picked second is different than the other way around. So we think of that as order matters. Okay, so in this scenario, order matters, right? They're getting different labels, okay? And so in that case, we call it a permutation. And when we did the getting ready for counting, okay, we saw there was a P and a C. So the permutation is P. Okay, so NPR, right? And this is the big set. And the R is the little set. So when I say big set, little set, I mean the number of items in that set. So if I have 28 students and I am going to pick 3 of them to get extra credit, and the first one gets 100 points, second one gets 50 points, and the third one gets 10 points, then I am going to use P. The big set is the big number of students, which is 28. So there is 28 students to pick from. and I am going to pick, how big is the little set? 3. I'm picking 3. So 28P3 is going to tell me how many different ways there are to pick 3 students where order matters, where one person gets 100, the second person gets 50 points, and the third person gets 10 points. So in your calculator, if you watched the, was it a video? Yeah, if you watched the video about how to do permutations in your calculator, then you do 28P3 in your calculator, and you should get 19,600. Darn it, this is what happens. I can't read my own writing. Give me 1 second. You guys should be doing this in your calculator too, to practice, to make sure you know how to use your calculator. So in my calculator, I'm going to do 28P3, and I get 19,656. That seems like a lot of ways, right? If there's 28 students, I'm only picking 3. I did not think there would be that many groups, but that's a lot of groups. Now I'm going to look at the same problem, okay, but instead of picking the 3 people, so I'm still going to pick 3 people, but now what if everyone gets 50 points extra credit? So instead of one person getting 100 points, another person getting 50 points, another person getting 10 points, I'm going to pick 3 people, right? But everyone gets 50 points, right? So just to clarify, I'm picking 3 people, picking 3 students. They all get 50 points extra credit. All right, so in this case, if I picked Miguel first and Savannah second, they would both be equally happy, right? In fact, if I picked Miguel first, Savannah second, Lewis third, they're all happy because they all got 50 points, right? No one got more than someone else. Okay. So we call this a combination, and we use this when order doesn't matter. Right? So order doesn't matter. Right? So they're all getting, there's either no labels or they're all getting the same label. Okay. And so that's the NCR. And again, this is the number of things in the big set. And this is the number of things in the small set. So when I do my combination here, I'm going to have, it's going to be a combination. The big set is 28. Okay. C, it's a combination. Order doesn't matter. The small set is 3 because I'm picking 3 items from the small set. And so in my calculator, I'm going to do 28C3. Now before we do this, I want you to think about the answer here. Do you think it should be bigger than the answer in the previous answer, the same, or smaller? Okay, so it should be smaller because now order doesn't matter. So Savannah first and Miguel second is the same as the other way around. So there should be less outcomes. Okay, so if you do that in your calculator, 28C3, that should be 3,276. Just gonna double check in my calculator. I don't always trust my own writing. 3,276. There you go. Notice that there's a lot less ways this time, and that's because the order doesn't matter. All right. Let's look at another problem. So let's say that the math club has 20 members. Okay. And they need to form a committee. So they need to make a committee of 4 people. So how many committees are possible? If, right, so what if they must pick a secretary, a treasurer, a president, and a vice president? All right, so notice that they are getting labels. So the order matters, right? Like one person's gonna be secretary, another person's gonna be treasurer. And so if Savannah's secretary and Miguel is treasurer, that's different than the other way around. So like the order matters. They're getting different labels. So this is what, permutation or combination? What do you think? This is going to be a permutation. So I am going to use P. What is the big group? How many things are in the big group? So 20 things in the big group. I'm picking 4 from that. So 20p4. Okay. So we're going to do 20p4 in our calculator. 20p4. You should try it out in your calculator too. So I have 116,280. It's a lot of different committees. All right, now one thing I want to point out that anytime you have a permutation is just a special case of the fundamental counting principle. So I'm going to write that down. Okay. A permutation is a special case of the fundamental counting principle. And remember, the fundamental counting principle is what we learned last time, and it's like filling in slots. So what that means is anytime you have a permutation problem, you could have also used the fundamental counting principle. The other way around is not true, but the permutation is a special case of the fundamental counting principle. So I could have used the fundamental counting principle, and I'm going to just show you real quick how. Remember, the fundamental counting principle is kind of like filling in slots. So we have 4 slots to fill. We have, we got to pick a president, a vice president, a secretary, and a treasurer. And when I pick the president, how many people do I have to pick from? Right, I have 20 people. Okay. And then somebody's going to be president. So then how many people would I have left for the vice president? And that would be 19. And then somebody gets picked for that. So we have 18 people left, and then 17, and we multiply those all together. Okay, I'm going to do it in the calculator. I better get the same number. So 20 times 19 times 18 times 17. And what do you know? I get the same thing, 116,280. Yeah. Okay, so that's only true for permutations. Combinations cannot be done that way. The only way to do a combination is with the C, and we're going to look at an example of that right now. So for B, everyone has the same responsibilities. responsibilities. I miss word where it just tells me if I spelled it wrong or not. Okay, now everybody has the same responsibility, so no one's getting any special labels, so therefore the order doesn't matter. So this is a combination, and we're going to use C. The big set is 20. The small set is 4. Let me get that 3 out of there. Small set is 4 because we're picking the 4 people. All right, but they all get the same responsibilities. So 20C4 is 4845, 4,485. All right, and notice that's fourth. Okay, give me a second here. 4,845. Missing a number. 4,845. There we go. But it's still a lot smaller than A because than the example that we did in part A, because of the fact that they're not getting labels, right? It's just picking any 4 people from the group. How many ways can I do that? All right, so for one last look at this problem. For C, we're still going to be picking 4 members from 28. But this time, they must pick a president, a vice president, and 2 regular members. All right, so if I asked you, hey, is this a permutation and a combination? Or I'm sorry, if I asked you if this was a permutation or a combination, I would expect you to maybe stumble a little bit. Maybe you might say both. Because notice that there's 2 things going on. There's a president, vice president. And there's also 2 regular members. So some of them are getting labels and some of them are not getting labels. So since some of them are getting labels, the ones that are getting labels is a permutation. So this part here is a permutation. And this part here, they're not getting labels. So this part is a combination. So we're actually going to have to calculate like these 2 parts separately. So to pick a president and a vice president, I'm picking 2 people from how many people? So there were 20 people. It's a permutation because they're getting labels. So that's 20 P2. All right. Now I need to pick the 2 regular members. Now 2 people are already gone because the president and the vice president were picked. So how many people does that leave for the big set? So that's 18 people left. And I'm picking 2 because I want 2 regular members. Okay. And then what am I going to do with those? Because we're going to get 2 different answers here. And what do I do with those? Remember, the fundamental counting principle says if like something can happen this many ways and something else can happen this many ways, then together they can happen how many ways? You multiply. So I'm actually going to multiply these 2 numbers together. Maybe I'll use a little times here. So I first have to find the answer to 20p2. So 20p2 is 380 times 18c2. Remember, it's 18 because there's 18 people left. And that is 153. So 380 times 153. And that is going to give us the answer. So 380 times 153 is 58140. So 58,140. Right. Just check my work real quick because I like to do that. So I'm going to just double check real quick. 20. I hope you guys were following along in the calculator because it's important to make sure you know how to use the calculator. So I got 380, 18, C2, I got 153, and then I multiply those together. 58,140. Love it. All right, so when we get to 5.4 part 2, we're going to do cards and lottery. So it's important to be familiar with a deck of cards. We looked at that a little bit in 2.1, I think, in the homework. You can always have a deck of cards in front of you, like an image of a deck of cards. But in the next section, we're going to do more counting, but we're going to look at counting cards and we're going to look at lottery tickets. So that's what we're going to do next time.